Laura, have people joined? I actually don't have the view I normally do.
Sure, yeah, some folks have joined.
Should we give like 1 minute for everybody to get on?
Yeah, I'd give another minute or two, then we'll get started.
Okay. I'm sure y'all heard that back and forth. So hello, everyone. We'll get started in just a couple minutes. Shout out to Peter McGuire. Okay, I'm getting antsy, so I'm going to at least start with my intro. Hey, everyone. I hope you're having a really good Safe+Sound week, and I hope you're going to do something fun to celebrate. Uh, my personal preference is a catered lunch. Hint, hint, OHD. So I'm Stephanie Lynch. I'm the Senior Technology and Research Manager at OHD. We're out of Birmingham, Alabama. And I think this might be our 5th year participating in Safe+Sound. We really love it. And we hope that people enjoy the free webinars, some free training. Today, we're going to be talking about respirator fit testing. We called it Breathe Easy because we're having a sort of campaign about that around our new product, which is a CNC respirator fit tester, which is called AeroFit. And we will be getting to that as we get into the presentation. So let's start learning a little bit about respirator fit testing. As I don't know where everyone is, I kind of want to just start with a little bit of foundation. So a respirator fit test is going to be when you use an approved protocol to evaluate whether or not a respirator is capable of making a good fit to a particular person. It's going to help you, going through a respirator fit test is going to help you verify training, which should have already taken place before the fit test. And then it's going to help identify that very specific make, model, style, and size of the respirator that's best suited for each employee. So you're going to offer typically a selection, and that's going to help you pick one that is capable of fitting. And then if you're really going above and beyond, you can, kind of work through which one is giving sort of the best fit. Although be cautious about using the fit factors in that way, and we'll kind of see why. So why do we do fit tests? So number one, of course, we're going to want to protect our employees. If our employees are exposed to inhalation hazards, then it's going to be really important for us to make sure that their respirator is at least capable of providing the expected level of protection. So we want to ensure that employees know how to use their respirator and help empower them, give them some peace of mind. I would really challenge you to, if you are doing respirator fit testing, to allow some time for your employees to maybe mess with the fit of the respirator on their face and go through an even second fit test. I know none of us have extra time, but if you really do, to sort of let them see maybe if they can get better at positioning their respirator in a particular way, or just get better used to using it. And this is, of course, dependent on how much your employees are using their respirator. Sometimes it might be more beneficial for those employees who don't get a lot of opportunity to use their respirator. But the main reason, unfortunately, that at least we at OHD see for people to fit test their employees is because it's required by regulation. So here in the US, it's required by OSHA, of course, but internationally, there's a lot going on in this space. So we're seeing a lot more requirements coming forward. One kind of note is that Sweden is going to make it obligatory, required in January of this coming year. You can see there a huge list of, it's just becoming more and more common to see that respirator fit testing is a requirement. One sort of question that we get to is who can do that fit test? So OSHA says, I think the exact term is a qualified person. But other standards mention a little bit differently. It's competent individual. Is it your program administrator? Is it just anyone? And unfortunately, OSHA has left this a little bit vague. And oftentimes, the requirements that you might see in other standards for all the things that would make a person qualified or competent to perform a fit test, if you knew all of those things and were able to identify that in someone else, then you're likely already the qualified person to do your fit testing. So it's sort of balancing that. So something we've kind of seen in this space, another sort of emerging issue in respirator fit testing, is accreditation schemes or qualification schemes. They have different names, but where there is a standardized way of evaluating a person's ability at performing a particular type of fit testing, and that's usually broken down between qualitative and then the two most common quantitative methods, so CNC and CMP, that we'll jump into later. And I hope that this becomes more common here in the US, because I do think it helps provide a really good level for making sure that you're getting a good fit test. This is a little bit embarrassing to say, but when I worked for a hospital for 7 years, and I was doing qualitative respirator fit testing for about 1,500 employees, and I was almost never failing anyone. And do you think that's because those respirators were just incredible in providing excellent fit? No, and neither do I. And looking back, it's because I was performing the fit test the way that I was taught. And it wasn't until later when I got into this space that I realized that the way I was taught was wrong. A qualitative fit test is going to take an appropriate sensitivity test, and then making sure that hood is good and filled, and adding additional squeezes of that nebulizer into that hood to make sure you're keeping that concentration up, the challenge agent inside that hood, so that then when the person goes to test their mask, it's giving it a really good challenge. And I don't feel like I was doing that. We'll talk a little bit more also about the differences between qualitative and quantitative. Getting a little ahead of myself. But so I do think that will help ensure that more people are getting good respirator fit tests. Okay, so when do we do a repeat fit test? So here in the US, it's going to be required to do it at least annually. Some other standards have a little bit different interval. Some have no interval. But in addition to that annual requirement, you are going to need to do it if the user has either gained or lost about 20 pounds. Good luck broaching that. I feel like the easy one might be like, hey, you look like you've lost weight. Let's do another fit test. But I can't imagine it would be much fun to go up to someone and be like, you look like you put on some pounds. Let's do another fit test. If they undergo substantial dental work or any facial changes, I have heard that even things like Botox can impact respirator fit. So just something to know. But all of those things, that's why you have to work on like culture and having a good relationship with your employees, right? Because like I said, it's very awkward to go up to an employee and mention some of these things or ask about some of these things. So you want them to understand the real benefit of a respirator fit test and how it is supposed to be part of empowering them and helping them sort of take some role in the protection they're being provided. And if there's any way you can make it a little fun, right? I know that's difficult, but anything you can do to just build trust with your employees so that when these types of issues come up, they're going to be able to come to you, and then it's not going to be awkward. It's going to be like, wow, hey, we really appreciate you coming to us. Let's do that fit test. And like I said, maybe kind of turn it into a little bit of a game or some sort of challenge where you see where you can get the best fit, if that's something that, again, time allows. I know none of us have time. Okay, so there are two overarching types of respirator fit testing. There's qualitative fit testing, which is a subjective test that's going to rely on the person who is wearing the respirator to detect the leakage of a test agent into the respirator. So that's going to be typically Bitrex or saccharin. OSHA has a couple other methods that are approved, but those are the two most common. And so that's just a pass-fail test. If you pass a qualitative fit test, then it's assigned a reference passing fit factor of 100. And that's going to be typically limited in most instances to half mask respirators. As far as quantitative respirator fit testing, that's going to be an objective measurement of fit. It's going to use a machine to measure some kind of leakage. It's going to provide you with a numeric value. So that's your fit factor that you're going to compare back to the reference passing fit factor for the mask. And it can be used on any respirator. So these are the two most common types of quantitative respirator fit testing. So there's controlled negative pressure, and that is OHD's sort of patented flagship product where we manufacture and sell the QuantiFit and QuantiFit 2. Our original instrument was called the Fit Tester 3000, if you have any familiarity. But we use air as the challenge agent, and we replace the filters with our adapters, and we use a controlled negative pressure within the respirator face piece to measure respirator leakage. Ambient aerosol, or CNC, or APC, you'll sometimes hear it called ambient particle counting. And so CNC stands for condensation nuclei counting. That's going to be our new instrument, the AeroFit. Also, some other competitors sell this device, the TSI Portacount or the AccuFit 9000. They're going to use aerosol as the challenge agent, and it's going to be carried out by probing the respirator and measuring the concentration of particles outside the respirator compared to the concentration of particles counted inside the respirator to figure out your fit factor. So these two technologies are doing or have very different ways of getting to the same thing, to that fit factor, to the evaluation of fit. So controlled negative pressure is a scientifically validated technology. It can be traced back to a NIST standard, and that controlled negative pressure is related to, like by science, to a modeled breathing rate. And that's what we use to measure respirator leakage. So one kind of easier way to think about it is you're thinking about the total amount of air that's going to be inhaled, and then that's going to be compared to the amount of air that would have leaked in, so that possibly contaminated air. And that's how we get our fit factor. So it's still sort of a ratio of like, inside, so contaminant, inside, we're counting all the clean air, everything you would have inhaled, compared to that contaminated air. So the ones that would have been counted almost like how you count on the inside. So counting air as opposed to the contaminant in the air, if that kind of makes sense. But the respirator is going to be equipped with those fit test adapters instead of filters. And the whole idea is that once you've pulled that controlled negative pressure that's related to the breathing rate, that then any air that leaks in, you're going to have to remove it. And so that air is counted. Whatever air you're having to remove to maintain that controlled negative pressure is the air that's leaked in. So it's going to measure that in cc's per minute with a series of exercises. That's another important aspect, is that both of these technologies have their very different approved protocols, which you can reference in the OSHA standard and we'll cover here. But the ratio of that leak rate to the modeled breathing rate is CMP's fit factor. So this is just sort of showing that process a little bit. We're taking the user, they're going to take a breath and they're going to hold it. And once they hold their breath, the machine's going to automatically detect that that breath hold has taken place. And then it's going to run the test. And all it's going to do is close off that mask on one side, and then it's going to exhaust air on the other side. And once it achieves that controlled negative pressure, any air that it then has to pull from the mask to keep that pressure maintained is going to be that air that is leaked in. So this is the approved protocol for CMP, and it's called read-on because there are 2 subsequent read-ons of the respirator during the test. So with the read-on protocol and CMP, you're going to put the respirator on, you're going to face forward, take a breath and hold it, and the machine's going to run its test step. Then the second step is going to be bending over. So that facing forward is just to duplicate, most normal breaths that you're going to be taking in that respirator. The second step, when you're bending over, you're testing the pull of gravity on that respirator. You're going to do the same thing. While in that bent over position, you're going to take a breath and hold it. The machine's going to run a test step. The third step is a little weird if you're not familiar with our tech, where you're going to shake your head and either exhale forcefully or shout, anything you can do to sort of break that seal. And that's going to test the ability of the respirator to reseat on the face. Then the fourth and fifth step are those read-onings. So you've already had, your user don the respirator at the beginning of the test. They're now going to go through 2 more read-ons. And with each read-on, they'll run another test step. So you're really testing the ability of that user to consistently get an effective fit with their respirator. That's one thing that we really like. And that's why we highlight the read-on part of that protocol, because that's been scientifically validated. So the redonning of the respirator to have more impact within a CMP test. So that's a better way for us to challenge the respirator. And that's why we have our own protocol. So benefits, you're going to have no environmental requirements. Our instrument's super portable. It's got battery power. The biggest limitation is that it is not able to test those filtering face piece respirators, those disposables. Some of the limitations that our competitors cite that I just wanted to point out are that the test subject holds their breath and that the test subject remains still during that actual test series. But just for the record, because it's just a very different technology, that is the best way for us to challenge the respirator, because we're breathing for the person, and our exercises are designed to just challenge the mask differently. So it's a little bit different way of thinking. I talked about this, but just to mention again, this is the way that we calculate with CMP the fit factor, the breathing rate divided by the leak rate. So that's that just total air inhaled divided by the possibly contaminated air that would have leaked in. This is a quick example of that, just to give a little bit more clarity. So our breathing rates are expressed in liters per minute, and that's just because of how you would want to be able to talk about it. And then our leak rates are expressed in cubic centimeters per minute. And again, it's just because of the amounts. So when you convert those, you can take that, let's use an example. So the 53.8 liters per minute, which is associated with our read-on protocol, you'll get that 53,800 cc's per minute of air, of total air, inhaled. Then if we got 1 cc per minute, if we had 53.8 cc's per minute leak in, then that just gives us some easy math to get that 1,000 fit factor. And we'll walk through the same stuff with condensation nuclei counting now. So this is our newest instrument. It's actually why I'm wearing my nice new shirt. This is supposed to match our AeroFit. But so this uses a laser technology to measure concentrations of aerosol both inside and outside a respirator to create a ratio. And the idea here is that because very few particles are going to penetrate a filter. So with this technology, with our newest technology, what you're going to do is you're probing the respirator, or you're using an adapter that fits in either behind the filter, and you're keeping the filters in place. So you're adapting the respirator or you're probing the respirator to be able to perform a CNC fit test. And you're going to run through a test where the machine is going to alternate between sampling the ambient air and sampling the air inside the respirator. And it's going to use that ratio to do a fit factor. So this is a graphic of that, and you can see how the machine is going to switch back and forth between whether it's measuring the ambient or the mask based on the approved protocol. I'm not sure if y'all can see my mouse, but so this is going to dictate which line is being sampled. So you'll see purge time in between, so that you're not counting, that lagged air from either the ambient or mask sample in your respective counts with your respective concentrations. And so it's going to go through the machine. It's going to get, it's pretty, like an interesting process where it goes through, and that particle is very small. And so it's going to pass through isopropyl alcohol, and that's going to condense on that particle and help it grow, so that then our laser is going to be able to count it. And there's a little bit more in-depth process that goes on with the ability to count particles for the filtering face piece respirators, and we'll talk about that in just a second. But these are the protocols for CNC respirator fit testing, so for our AeroFit. And they're different based on whether you're testing elastomeric respirators or you're testing those filtering face piece respirators, which this technology is very capable of fit testing. So with these fast fit protocols, you can also get very quick testing done. We like with CMP that it's very fast, but with these fast fit protocols, our AeroFit, so our CNC test can be very fast too. But it's going to have a bending over step for the elastomeric respirators as the first step. Then you're going to do a comfortable jog in place, which does look a little funny, but it's a good challenge for the respirator. And then you're going to put your head as far as you can to one side, take a couple breaths, and then move your head as far as you can to the other side and take a couple breaths, because we're trying to hit those extremes, right? And then same thing with up and down. And then the only difference with the filtering face piece respirators is that those are challenged with talking. And that's because the research showed that that was a better challenge for those particular respirators, whereas the jogging maybe helped challenge the respirator, the elastomeric seal, in a little bit different way, based on the kind of work you might be doing if you're using an elastomeric respirator. I think that was some of the justification for that difference. So with that, talking about how CNC can test the filtering face piece respirators, one thing that might be important to note is that when you keep hearing that N95 designation, it's sort of important to realize that that has meaning. So the N is actually dictating that that respirator is not resistant to oil. And this is all stuff that's put out by NIOSH. So NIOSH is who certifies all of our respirators to include here in the US, to include those N95s. But so there are N95s, there are N99s, and there are N100s. And then there are also series that are a higher level of resistance to oil that are called R, so resistant, and those come in the same designation. So R95. I'm actually noticing that our numbers are a little bit messed up right here. So this should say R95, R99, R100. All of those are designations that would be available. And then P series is the ones that are actually proof. I'm actually seeing that now these are reversed too. So sorry, you guys. So it should be N is not resistant to oil. The R has some resistance to oil. And then the P series is strongly resistant to oil. And the P is actually kind of, we say, for oil proof. And that helps you remember those designations. I don't know how this slide got so messed up, but then, so these should be switched. And then these values should all be switched. And these should also be listed as 95, 99, 100, as if that's not confusing enough. Okay. So I just helped it be even more confusing. But so with those N95 respirators, because as much as 5% of those particulates in the air could be expected to penetrate through that filter, it makes it a little bit more challenging to use CNC to fit test those respirators. So with the AeroFit, we had to move to a particle size for the respirator where it was going to have very strong protection. So the way that NIOSH challenges respirators is there's a particle size that's considered the most penetrating particle size. And that's sort of in this range here. And so what we wanted to do is push where we're measuring outside of that most penetrating particle size and into a particle size where the filter performs very, very well. And then that allowed us to test N95 respirators. And that's the same for all of the CNC respirators. So the biggest benefit with CNC and with AeroFit is that you're going to be able to fit test any tight fitting respirator to include those filtering face piece respirators. That being said, it has some of the limitations like environmental requirements. You're going to have to make sure that you keep a good particle count in the air. And at OHD, we've tried to help your particle management go very smoothly. You are going to have some consumables with that. You got to use the alcohol. You're going to have to, you'll have a wick that you're saturating that gets inserted into the machine for all CNC fit test equipment. And you're going to have to ultimately replace some of those wicks. And then you shouldn't have the test subject this also applies for qualitative fit testing. The test subject shouldn't eat or smoke for 30 minutes before the test. And that's because they'll be producing particles in this instance, but for the qualitative testing, it's because it could interfere with their ability to test the challenge agent, right? Which totally makes sense. So I mentioned this, but just to keep everything in order. So we're going to take with a CNC fit factor, completely different from CMP. We're going to take the concentration of the particles that are sampled outside the respirator, and we're going to put that over the concentration of particles that's counted inside a sample within the respirator. So just to do some easy math again, if we had an average ambient particle concentration of 6,000, and then we counted a concentration of 6 particles within the respirator, that would give us that 1,000 fit factor. And sometimes that's like a little bit easier to understand, but something that then makes it a little bit more confusing. We have qualitative and quantitative, then we have CMP and CNC. And as if it wasn't already confusing enough, our overall fit factors for both technologies are calculated actually in the exact same way. So once we take those individual fit factors that are calculated in their very different ways, right? We're all using an overall fit factor formula that's called a harmonic mean. And so this harmonic mean is going to help place higher weight on the lower values. And that's going to help our fit factors be more conservative, right? By placing higher weight on those lower values and pulling that score down, we're going to be able to be a little bit more conservative in our evaluation of fit. So this is just describing what a harmonic mean is. This is just a common way of doing things in mathematics, but this is going to lessen the impact of those larger outliers. So help make sure that if you get a really high fit factor, it's not going to pull it up as much as a just standard average would, as your mean would. And it's going to make it where if you have one bad value, it does more to pull that overall score down. And that's just important, right? So if you looked at these numbers and did just a straight average, you would get a fit factor of 1,000, like we've been talking about in the previous examples. But because it's a harmonic mean, it's, like I said, going to place greater weight on those lower values. So you actually get an overall fit factor of only 862. But that can still, you see how using the same way might make it a little bit more confusing. It might make it seem like the fit factors are equivalent. They're not. And that's another thing where I mentioned, you can use fit testing as a tool to help people maybe figure out their best way of of the mask sort of situating on their face. And that's true to an extent when you see maybe like a big difference. But it is important to recognize the limitations of that, right? So if one mask feels more comfortable and you get a pass on that mask, but another mask is maybe less comfortable and you get a higher fit factor, this mask is still perfectly approved. The more comfortable mask is the one you should go with, because if it's more comfortable, that's the one you're more likely to wear. And so that's where, the fit factors have some ability to be compared to each other, but it's important to recognize the limitations. When you have a person involved, that's already a lot of, added issues. So you just have to think that with each donning, that's a completely different fit, really, to the person. So we want to, use it where we can, but not overstate its impact. And guys, this is not usually like me, and I guess I really want to be done with my day, but I've gone so fast. Does anyone have any questions? Okay, I see one question in the open question and answer. So are the modified CNC fit test protocols, the shorter protocols, approved in California? I have actually heard that they are not approved yet by Cal OSHA, but that they are under consideration. So I think it should be forthcoming. Now, that being said, I still think you could use those protocols and justify OSHA's federal approval as the reason why you've done a shift, but you would want to check with one of your regional offices to see if that would be acceptable. Does anyone else have any other questions? I do feel like most student groups are at least a group that don't mind getting, a little bit less learning. So I hope you got what you needed. And I'm sorry that I went so quickly. I usually have my notes, and maybe that's what slows me up, but it was just a pleasure to be here, and we're happy to participate in Safe+Sound. We have 2 more webinars, one on noise tomorrow, and then one on heat stress prevention and monitoring um, on Thursday. Thanks again, Peter. Thanks for being here. It was a pleasure seeing you at Safety 2024. Yes, anonymous. It says, thanks for providing pros and cons between machines. We're priding ourselves at OHD with making a CNC machine to be more unbiased. That's the goal. We want to be your fit testing experts and not just your CNP experts. Okay, I'm going to stop. I hope everyone has a good day.